Now we're going to move into our session number 2, Reconsidering Community and Geographic Contexts. The next session is going to be chaired by my colleague, Tracy Kugler. Tracy joined IPUMS in 2011 as project manager of the IPUMS30 project, and now serves as the co-principal investigator for the International Historical Geographic Information Systems, or IHGIS. Come see Tracy's poster this afternoon to learn more about that project. In addition to her role on IHGIS, Tracy also serves as the co-director with Audrey Durelian of the Population Studies Training Program at the Minnesota Population Center. So I'll turn it over to Tracy to introduce speakers, and we'll get our next session going.
All right, thanks, Dave. I am pleased to be presenting this session, which looks like it'll be really fascinating, at least for me and other spatially minded folks. Hopefully the rest of you as well. Our first speaker is Peter Rich, who is an assistant professor in the Department of Sociology and the Jeb E. Brooks School of Public Policy at Cornell University. Peter is a spatial demographer who studies how systems of segregation and inequity emerge at the intersection of geography, public policy, and family choice. His work on spatial stratification has investigated the contextual origins of Black-white gaps in educational outcomes, the impact of charter schools on residential and school segregation, the role of information in the school choice process, and in today's presentation, the effect of historical court desegregation orders on family neighborhood choice. Peter holds a PhD in sociology from New York University. Welcome, Peter.
Well, thank you, everybody. Thank you so much, IPUMS, for all of the data that you've produced for us, provided for us all these years. I'm happy to be here to be celebrating this 30-year anniversary. I was telling my wife, who's watching the live stream, this is like one of the first times she gets to watch one of my talks, so this is great. I was telling her that my mug that I got, I'm celebrating the 10-year anniversary of the mug. So there may be a picture of that in the slides if I get to all my slides. So the work that I'm going to show today is going to involve some additional data from the panel study of income dynamics. They're restricted use files. So just want to let you know that anything that I present for that's restricted data, is my work alone and conceals the identity of the research subjects. So I'm going to start with a sort of long-running puzzle in the empirical literature, which is that the racial composition of city school districts changed substantially between 1970 and 1990. We see a big drop in the number of white children aged 0 to 15 who lived in city school districts over this 20-year period. And what this did is it led to a drop in the percentage white students who lived in school districts and then who were attending those schools. And the big question that has been asked time and time again is how much of this is attributable to school desegregation policy? So school desegregation policy, I'm going to give you a 30-second primer. There was a pre-1970 period where there were a lot of really important symbolic changes that happened that opened the gates to enable some level of school integration to occur. But it wasn't really widespread until after 1968, when the Supreme Court sort of greenlit more activist-related like busing programs and so forth. And so in the period in the 1970s onward, which is where I'm going to be focusing on, there were really ambitious projects that reshuffled students across from disparate neighborhoods to attend integrated schools. And this happened in school districts across the country on a kind of rollout basis. And it's also been sort of credited for accelerating white flight out of cities. And none other than Joe Biden has described it as a liberal train wreck. There's a long-running narrative that says that this was too ambitious of a progressive policy and that it made things potentially worse. So I'm interrogating that. But the other thing you should know about this is that this is like a classic question that has been studied for a really long time. James Coleman came out with a report in 1975, sort of cautioning about this. And there have been a lot of heavy-hitting papers on this, including there's a great one by Nathaniel Baum-Snow and Brian Lutz, and there's a recent one by John Logan and co-authors. But it's always been using population level counts. And that leaves a lot of questions unanswered. As a demographer, I'm worried a lot about ecological fallacy when we're looking at population level processes. And so that led me to ask this question in a slightly different way and to think about underlying micro level processes. So James Coleman, actually, he got dinged quite a bit for that report, but he's also a hero in this story because he also came up with this book, Foundations of Social Theory, where he really thought a lot about micro macro processes, and that's what I'm going to be doing as well. So the research design here is I'm going to do a micro level analysis of household mobility. And this is the first micro level national analysis using the PSID to look at where families moved relative to desegregation. And I'm going to do some causal estimation on the likelihood that households moved out of the school district that they were in if it was treated by desegregation policy, and also whether it changed the likelihood that families would move into those neighborhoods. So I'll look at inflow and outflow. And then the innovation here that I may not get to because it's pretty complicated is to then look at counterfactual simulations that link how do these micro level inflow and outflow tendency changes, how do those scale back up to explain the population change that we see. And we see that population change from data that NHGIS has made available. So I'm using a geographic linking process to identify the neighborhoods that are nested within school districts historically, and then summarize the population change from there. So because I mentioned that this is a quite involved process, especially the simulation, I'm going to preview the results for you, which I think are a little bit more surprising than maybe we expect, more than what I expected. So the empirical argument that I make is that desegregation did trigger a 7 percentage point drop in the metro share of white households living in city districts between 1970 and 1990. So what I mean by that is if you take any given metro area on average, the percentage of white kids age 0 to 15 who we observe, the proportion who are in the desegregating district versus one of the other suburban districts. Desegregation triggered a 7 percentage point drop, but about half of that came from flight. The other half came from a change in the behavior of people moving in. So white families were less likely to move in to these desegregating districts from the suburbs into the cities, on top of any other existing avoidance that already existed. So what also happened is that the share of Black children moving into those city districts increased by 12 percentage points during this period. And so this reveals itself in the data. The combined effect of that explains a good amount of the drop in city school district percent white, but there's actually another factor in play here, which is that there's differences in the sort of the age profile of the families who lived there even at the beginning of this period. So there was naturally baked in a white population loss that was happening because of demographic inertia. So essentially families with kids were more sparse even before desegregation ever hit, and they weren't having kids at the same rate. And so because of that, the city decline was happening as well. So I'm kind of pulling apart these different processes to help us understand what exactly happened. So to give you a bit of the conceptual framework here, the macro level story that we're used to is that mandated desegregation had some effect on the white population living in city districts. And the sort of Coleman boat way of thinking about this is that underneath it, it's because white residents, they experienced this direct effect. They moved out of the city district, and then that caused this decline. And the other layer that I'm adding to this demographic process is that there were indirectly treated families as well who lived outside of the city district, but it sort of desegregation led them to start avoiding even more moving into the city. So that's the sort of general framework here. But this demographic inertia part of the story is that if there are differences between cities and suburbs, that's also going to affect things. And if our models aren't picking that up, then we're missing a part of the story as well. So I'm going to first walk you through the macro to micro story. I did not realize that Goodman-Bacon was going to be here. But let me showcase the data sources, and then in the Q&A, I'm happy to address problems. It is going to be an event study project. So I have from the PSID, I know where families lived every year starting in 1968. I'm going to follow every family and their offspring through 1990. At the metropolitan and district level, this is where NHGIS comes in a really huge way. So what I was able to do is link using block level data, 2010 block data, link to the boundaries of school districts going back over time, but then also link that to census tract data and create weighted estimates of what the district conditions were, the school districts, in 1970 and every 10 years. So that becomes contextual data, but it also helps motivate the project. And then I also bring in the history of desegregation orders. That's been produced. There are a lot of papers that have kind of added to this growing data set where we know the timing of when desegregation orders hit. So don't worry about reading this table or looking at these maps too closely. I just wanted to showcase a little bit of the work that I did to make this all work. So I've looked at identifying which school districts are the ones that overlap with cities. So the darker gray parts of these 4 maps are the sort of city boundaries. And so you can see that there's cities and then there's suburbs, and how we think of a city school district varies across different kinds of geographies. And so what I'm really focusing on is the kinds of cities where school districts where the city and the school district match really well. Like Chicago is a really good example. That's in the top left. And then in the top right, you see Charlotte, North Carolina, where there was a really big desegregation order. And most of the central city is encompassed within the boundaries of that larger county district. And so what I was able to do with NHGIS data is get an estimate of a couple of things. So one is just what's the share of residents living in city versus suburban districts in each of these metro areas that were treated. And then to also get a sense of over all of the deseg orders that happened between 1970 and 1982, how many of them were happening in each year? And so that's going to be important in the simulation and reweighting, which I've teased that I probably won't get to. And so the underlying micro-level model is an event study model, which looks at where families are sorting relative to the timing of desegregation. The 2 key questions I'm asking are distinct based on whether families lived in a district that desegregated or they lived outside in the 2 years prior. So I focused the analysis on 107 metro areas that didn't have any desegregation orders prior to 1970. 51 of those eventually did have some kind of an order. And the key identifying assumption here is that the timing of when the exact order hit is essentially random. It's due to court processes. And this identifying assumption is really common in the desegregation literature. So I'm adopting that to try to get at what's happening here. So I have different event time indicators that are going to pick up treatment effects based on the assumption that what we observed 2 years prior, the kind of sorting patterns, tendencies we see 2 years prior to a deseg order are effectively what we should have expected in the absence of any desegregation policy. And then I'm going to be controlling for different metro level controls, calendar year, fixed effects. I actually don't use metro level fixed effects in this because the sample power gets a little weak. So this is the white flight story that I want to emphasize to you. So in the pre-period, we have about a 6% likelihood of white families moving out of the types of districts that desegregated before people knew they were going to desegregate. And then you see this spike that happens during the implementation years, year 0 and year 1. And then a sort of continuation period that remains a little bit high, but sort of stabilizes. There's a lot of heterogeneity questions that I'm unable to get at with PSID data, but at least it gets us on the map of a sort of familiar story. And then this is the white entry story. And so you see that prior to desegregation, you have about a 3% likelihood that a family out in the suburbs or somewhere else might move into a city. And then that drops during the implementation period and continues to drop. One thing to note is that these are predicted probabilities from an individual perspective, but the size of the populations are very different between city and suburb. And so the broader sort of macro question is, how does that all scale up? And so the intuition of what I do is really I just run this simulation thousands of times. I let every family be where they're observed in a city or a suburb, and follow them over time, allow them to have kids at whatever rate we observe them. So I build in a lot of the demographic processes. But in each year, I assign them based on their predicted probability of moving, the condition about whether they'd be in a desegregated district or not, and then update and then predict again. So I do that again and again. And over time, that gives us a sort of distribution of where we expect families to end up by 1990. And doing it thousands of times gives us a sort of nice way to smooth out some of the stochasticity in the process. And so then I do that again, but I just turn off in the prediction model what desegregation is doing. So I essentially assume desegregation didn't exist, and then from that generate a counterfactual. So to give you the intuition here, this is what the predicted model looks like when fully expressed. And then this is what it looks like when we turn off desegregation policy. So we get this sort of nice population level counterfactual estimate of the percent share. And then I can do that for Black families as well. That was a part of the analysis that I didn't highlight just yet. But we see this big bump. Now, this is simulating a plan in 1974, but there's this problem, which is that there are different plans at different years over the course of the study, and that the proportions who are living in suburbs or cities also varies across different years. So I'm going to re-weight everything based on that to get at a sort of broad overall estimate. And that's where I get to the results that I highlighted. So in my final minute, I already showed you that slide intentionally. Let me just tell you why I think this is important for us to be looking at today. So first, we want to really unearth the complexity underneath population trends we can observe. We want to estimate micro-level policy effects, but that's not enough. The micro-level policy effects that we see, you can pick up real effects in the study that I'm doing. But the question is, what's the scale of those effects for the population processes that we really care about? And this is important because there's this unintended consequence narrative about desegregation policy that actually kind of dominates the political narrative. And desegregation policy was very effective in supporting Black students on all sorts of outcomes that other work has shown. And but it has very little political favor, in part because of this unintended consequences narrative, which when we put it in proportion, the flight story is actually about a fourth of the story. Part of it's reduced entry, but actually half of the story is that the populations were changing naturally based on preconditions that were set in previous decades. So I'll end there. There's my mug. Thank you so much to IPUMS and to NHGIS for enabling this kind of work to happen.
All right, thank you, Peter. And I can kind of stand off to the side here if you want to start getting your slides set up, Brian. Our next speaker is Brian Thiede. Brian is an associate professor of rural sociology, and demography at the Pennsylvania State University, where he is also an associate of the Population Research Institute. His research focuses on the effects of climate change on migration and population health around the world. Welcome.
Thanks. Yeah. Thanks. It's a real honor to be here. I won't rehash what was already said, but big thanks to IPUMS, this project. These data have been foundational to my career, as well as that of many of my collaborators and my students. So I'll be presenting some research today looking at the relationship between climatic variability and internal migration in Asia. I want to acknowledge my two co-authors. First, Abby Robinson, who's currently a PhD student in rural sociology and demography at Penn State. And she also just recently, last semester, defended a really nice master's thesis that used IPUMS DHS data to look at the effects of drought exposures on child marriage in Mali, which was excellent, and I hope you'll see soon as a publication. And then also Clark Gray, who's a geographer at UNC, who's also very active in IPUMS. He's on the IPUMS International Advisory Board and also a prolific user of the data. So this is really an IPUMS centered team here. Our overall goal here is to look at the association between exposures to different types of climate anomalies and internal migration across 6 countries in Asia. I'll talk a little bit about our motivation, objectives, empirical strategy before I get to results. And if I have time, I'll talk about some limitations. But in case I don't get to anything, I do want to preview the main findings, where we find that exposures to precipitation deficits, in some contexts droughts, those are associated with reductions in migration across the region. This is contrary to some of the common narratives about climate change displacing populations, which I think is notable. And we also find evidence of variation in these relationships across different demographic groups and by the distance of moves, but these are quite limited and really substantively not that important. But we do find quite large cross-national variation in these relationships. And we also finally then find that the observed precipitation effects, we find some suggestive evidence that they're driven by changes in labor migration rather than other types of moves. So before I get to the actual paper, I want to give you a sense of some of our motivations, and we're really motivated by three main observations. The first is that the links between climate and migration have received widespread attention. In many contexts, this attention has been driven by kind of sensationalist or strong, if not sensationalist, claims about the potential displacing effects of climate change. In the groundswell report, for example, suggesting that you could have hundreds of millions of internal climate migrants by 2050. And a large number of studies in this literature do indeed detect these effects, but both the direction and the magnitude of these effects differ quite a lot from study to study. So the actual empirical evidence is quite a bit more nuanced than you might see in some of these big headlines. Importantly, however, it's very difficult to determine if the differences in effects across studies are driven by actual substantive differences in these relationships, or if they're just artifacts of different data and methodologies. And this is where IPUMS is really useful, because we can actually apply a kind of consistent analytic framework to harmonize data to actually make these comparisons without some of those concerns. We also note that very few studies in this literature have looked at differences by the distance and type of migration. And here again, we try to exploit IPUMS data to get at some of that. The second motivation is that there are really strong theoretical conceptual reasons to expect a relationship between climate exposures and the downstream effects, and then ultimately changes in migration. This isn't really the time to get into all of these mechanisms, but I would just point out that a given climate shock could potentially operate in kind of different and even contradictory ways through each of these mechanisms. So it's ultimately kind of an empirical question about, the direction and the strength of a given effect, the effect of a given climate exposure on migration, right? So that's kind of a point of departure. Theoretically, we don't have a directional hypothesis. We treat it really as an empirical question. And then third and finally, we just acknowledge that migration is a really important outcome. Socially, economically, demographically, it's associated with many important demographic and social outcomes. And it can also be an important part of climate adaptation strategies. So it can actually be a good thing in some contexts that are affected by climate shocks. And so we want to acknowledge that. So like I said, our goal is to look at the association between climate exposures and internal migration in Asia. We look at differences in these associations by age, sex, and education, which we broadly expect to be correlated with differences in vulnerability. And we also look at differences by country of residence. We also then conduct analyses where we disaggregate our migration outcome by distance, which we roughly proxy by looking at moves to adjacent and non-adjacent provinces. So if the destination is adjacent to the origin or not. And then we also look at self-reported types of migration, so work-related moves, family-related moves, and education-related moves. We're drawing on census and survey microdata from IPUMS International. We're using we're restricting our sample to countries in Asia that have the harmonized geographic identifiers for the place of residence, both at the time of the census and the survey and 5 years prior. And we also limit our sample to countries with at least 2 rounds of data that have that information, right? Because we need to be able to have multiple observations per province for our approach. Our sample then, we have data from China, Indonesia, Malaysia, Nepal, the Philippines, and Vietnam, data coming from between 1985 and 2011. We restrict our sample to the ages 15 to 49, kind of the the prime migration years, and that gives us a sample size of a little under 55 million. We then link these data to climate data that's coming from the University of East Anglia's Climatic Research Unit's time series. These crew data are based on the statistical interpolation of about 4,000 weather stations globally. And we take monthly temperature and precipitation records from 1981 to 2020. The data are produced at a 0.5 degree resolution, but we collapse them down or up to the province level as spatial means. So we're measuring province level temperature and precipitation conditions, which is what we can do here, given the geographic information in these data. So we're using binary and multinomial logistic regression models, and we focus on 3 different outcomes. So our main outcome is just inter-province migration over a 5-year migration interval. So did someone move across province boundaries or not? We then disaggregate it by distance, as mentioned, and by type. The one thing I want to mention is that our analysis of migration by type is restricted only to those countries that have sufficient data. So we're limited to China, Indonesia, and Nepal, sample size of a little over 15 million. And there we're using the IPUMS source variables that have kind of the unharmonized information about the reasons for migration. And we looked at those and as a team kind of found an agreeable way to code them into the typology that I described before. Our main predictors are temperature and precipitation anomalies. We measure those over the same 5-year migration interval that we're measuring that outcome. And so these can basically be interpreted as z-scores. So for each province, we're looking at the temperature and precipitation during that 5-year period. And then we're expressing that as a deviation from the long-term mean in that location and expressed as over the standard deviation of that temperature and precipitation for all those 5-year, for a 5-year running average, again, in our climate history for that location. We include quadratic terms to account for potential nonlinearities in these temperature and precipitation effects, and can discuss alternative ways to maybe getting at that in the Q&A if helpful. And we're controlling for age, sex, educational attainment, and include province and decade fixed effects. So I'll begin with our overall estimates. Again, these are from the model that's looking at the binary outcome of inter-province migration across our entire sample. We don't find any association between temperature exposures and migration, but we do find that precipitation is significantly and non-linearly associated with migration. To illustrate this, what we do is we generate predicted probabilities of inter-province migration across a range of precipitation exposure values, holding all of their variables at their mean. And so this is the 0 would represent what we'd expect under average precipitation. -2 would be 2 standard deviations below average for that location. And obviously +2 would be 2 standard deviations above average. So a precipitation deficit or precipitation surplus, excessive precipitation for that location, and a precipitation deficit. And what we find here is that we find a fairly steep reduction in the likelihood of migration as precipitation decreases, right? So if we would compare what would happen under average conditions, we'd see about 2% probability of migration, and that would go down to 0.8% under a precipitation deficit of 2 standard deviations below average. We don't find the same thing as precipitation increases, so suggesting that this relationship is really driven by what's occurring with these precipitation deficits. And I don't want to call them droughts because there's a technical definition of that, which we're not actually getting at here. We then look at heterogeneity across groups. So we find no, and I'm going to focus here on just precipitation. We also look at this for temperature, but for simplicity, we'll focus on precipitation. We find no differences in terms of by age. We do find statistically significant differences by sex, but as you can see here with these sex disaggregated predicted values, substantively, there's not a major difference here. We still find the same reductions in migration for both men and women as precipitation falls below average. And the same thing is true here in terms of educational differences. Okay? So statistically significant, but substantively not to be overstated. Our next step then is to look at spatial heterogeneity. So we estimate or we fit country-specific models. And I would just want to, again, for brevity, highlight 2 points. So one is that only in 3 countries are precipitation effects statistically significant. And we find some differences in the actual patterns, the direction of these effects. So again, this is similar to our figures, but in table form. These are the predicted probabilities of migration under average conditions. I'll point you to the values for precipitation deficits. And in this case, what we find is we find reduced migration in China associated with those deficits, as well as in Malaysia. But we see a slight increase in Vietnam, suggesting that this relationship varies significantly substantively across the countries in our sample. This is obviously a very rough way at getting at kind of important dimensions of spatial heterogeneity, but I think it raises some important questions for future work. I'll then quickly go through our final results. We then disaggregate migration by distance. And again, we find fairly similar patterns between moves to adjacent and non-adjacent provinces, which is potentially surprising, given what we might expect in terms of how different types of migration might fit into climate adaptation strategies. And then again, with a limited subsample, we look at differences in migration according to the type of move, right? And we see for worker-related moves, a significant reduction in migration associated with precipitation deficits. Excuse this figure, the axes are such, they're like this for comparisons with other types of outcomes in the actual paper. But this is actually a meaningful reduction in work-related moves, but we don't find any such relationships with education and family-related moves. Okay. So just to wrap up really briefly, again, we find that overall these precipitation deficits are associated with meaningful reductions in internal migration. We find some statistical differences across demographic groups, but substantively not what we might expect given expectations about differences in vulnerability. And we also don't find very meaningful differences in climate effects on migration by distance. We do find this large differences across countries, which raises important questions that I think we need to dig into more in terms of spatial heterogeneity. And again, looking at a subsample of the data, we find suggestive evidence that our overall effects are driven by labor-related moves, which is consistent with kind of the expectations in the literature. Yeah. I do have some limitations and extensions. We can talk about these more in the Q&A, but I would just highlight one kind of big limitation that I think is important for this general literature is that we're just looking at overall associations here. We don't have very good data on the causal mechanisms, right? And as I showed in that initial slide, the potential mechanisms that drive the relationship between climate exposures and migration are multiple, and they might not operate in the same direction. And so I think an important next step here is to start thinking about mechanisms and trying to get at that empirically. I'll finally end by just saying thanks again. This is a very, very non-exhaustive list of IPUMS-based papers on climate and migration. Like this is like your first page of results in Google Scholar kind of thing. And there are many more that I could list, but I think IPUMS has been foundational in terms of moving this literature ahead and going from some of the kind of sensationalist headlines to actually producing good empirical evidence that really supports a much more nuanced and I think valuable picture for policymakers and people worried about displacement around climate change. And so this has been really important in terms of moving this literature forward. So thanks a lot.
This time it is our own Elizabeth Boyle, who is a professor of sociology at the University of Minnesota with a joint appointment in the College of Law. She was recently awarded the Harriet B. Presser Award by the Population Association of America for her global research on women and children's right to health. Her current work focuses on the ways in which political and environmental contexts interact with social conditions to influence health outcomes. Welcome, Elizabeth.
All right, well, it's so great to be here. I have to say it's a little bit of a surprise. Monica Grant from University of Wisconsin-Madison was actually going to present, but she had an issue that made her cancel at the last minute. And so folks asked me to step in, and of course, I'm happy to do that. But I'm actually super excited to do that. But I do want to kind of give you a little heads up that this isn't as polished as I would like it to be. But I'm really excited to get your feedback. All right. So I'm going to be talking about community characteristics, particularly demographic characteristics, and we're especially interested in those related to gender. And armed conflict. And this is comparative research that we're doing with IPUMS DHS. Okay, so just to give you a little, I want to tell you a little bit about IPUMS Global Health, along with Miriam King and Kat Grace. I'm one of the PIs on IPUMS Global Health, and I'm going to be talking a lot about IPUMS DHS today, but I just want to mention last week we had IPUMS Mix released, yay. That's the multiple indicator cluster surveys, which are coordinated by UNICEF. And we have data on 88 countries. Mix is really interesting because it includes unique record types like teenagers, which you don't usually have information on globally. And UNICEF is working on adding more geographic information to that data, which we'll of course incorporate into IPUMS when we have the opportunity. And I should also do a shout out to Anna Bolgren, who's probably here, who's the project manager for that. Hi, Anna. Then also IPUMS PMA, which has been funded by the Gates Foundation, has questions similar to the DHS, and it's also geocoded, but it has the advantage of frequent surveys and also service delivery, that is health service delivery providers, and geocoded information on them so that you can link individuals with the service delivery providers that are closest to them. Okay. I also just wanted to briefly mention some news about IPUMS DHS. So Miriam and I were awarded a new climate change and health supplement from NICHD, sorry, not NICHS. And it incorporates all of the malaria surveys, and it's also going to allow us to help users access geocodes directly through IPUMS, taking advantage of the harmonization in IPUMS. And Kat Grace and Audrey Dorelian and other folks are working on a climate change and health dashboard, which will give individuals useful guidance in terms of using this new information for research. We've also simplified the calendar data. And if you want to learn more about that, check out the recorded webinar that's online. All right, great. So now let me talk about my research. So this is research using fine-grained contextual information. And I'm interested in the demographic influence on the onset of armed conflict. I want to acknowledge my collaborators, Nir Rotem, who's a former graduate student, and Ilana Laskar, who's a data scientist. Nir is now at Hebrew University, and Ilana is in private industry. And I should say that Ilana is really the technical expert here. And so I'm super interested in your questions about the technical models, but I might not be able to answer them myself today. So I'll just record them for her. Okay. So let's give a little bit of background. So predicting armed conflict has been something that policymakers and political scientists have been interested in for a very long time, because if you can predict armed conflict, then you may be able to avoid the outbreak of armed conflict. Models in this area initially focused almost entirely on national political characteristics and looked at whether conflict broke out within national boundaries. But recently there has been more of a focus on topographical environments, and I'm using topographical in a broad sense, but like if a place is mountainous, if it has more cropland, but also how close is it to the nearest city? How close is it to the nearest resource, like a diamond mine or something like that, that might be a source of resource conflict. To date, it's very rare to draw information from surveys to add to these models to potentially improve prediction. But there are some studies. So Hiroshi et al. Found that communities with greater levels of pro-government support in Afghanistan were more likely to be targeted by the Taliban. and that used survey data. And Blair and colleagues have used survey data in a study of violence in Liberia, and found relationships related to ethnic, I would say, ethnic cooperation and ethnic conflict being related to the outbreak of conflict. Specifically thinking about gender and armed conflict, at the national level, research has shown that women's empowerment, that is a representation in legislatures, is associated with a lower likelihood of conflict. And also countries with attitudes that are more supportive of gender equality tend to have less armed conflict. So there's some previous research that would suggest that gender empowerment, it does matter. So our core question is, do community level demographic variables improve models predicting armed conflict? Okay. So the methods that we use, first, we are taking 45,000 DHS enumeration areas from 32 African countries between 1997 and 2018. And we're using the integrated demographic information from IPUMS DHS and linking that with armed conflict and other information from PRIO-Grid, which is provided by Uppsala. And the PRIO-Grid information is drawn from the year after the related DHS survey. So our sample is really based on DHS surveys across Africa. And then, of course, most a year after that, the vast majority of places have no armed conflict, but you will see that a small percentage of the locations do have armed conflict in them. So that's what we're aiming to predict. After we integrate these, we have 9,230 cell observations. And what we do is we associate each enumeration area centroid with the appropriate PRIO-Grid cell and aggregate across the enumeration areas that are in each PRIO-Grid cell. Okay. I also should say, with respect to the lag, where we're looking at the DHS data first to get the demographic characteristics and then the conflict later, analytically, we think that lag makes sense because, of course, we're imagining that characteristics of the demographics are either increasing or decreasing conflict, but methodologically, it also helps to deal with a weakness of survey data, which is that surveys often aren't taken in places where there's armed conflict. But by looking at DHS surveys a year ahead of time, we, to some extent, get around that. So our analytic strategy is to examine the predictive value of conflict, for conflict of a series of national level variables that include things like political system, nature, or the level of autocracy, those kinds of things, local geography, which I've already mentioned some of, and then local demographic conditions, including gender and child-specific demographic conditions like child stunting and child wasting. And we're using a machine learning reverse ablation approach with random forest models. And the way that this works is the data is divided into a training set that tries to identify patterns and then applies what appears to be the patterns to an additional out of sample tests or out of sample data. So we say 75% of the data is used to create the model, and then that model is used to see if it can predict conflict for the other 25% of the sample. And we use a balanced approach to account for the low probability of armed conflict. Okay, so talk about the results. I wish this was a pretty picture, but unfortunately, it's just going to have to be discursive. I do have a pretty picture after this one, though. Okay, so what we found was that the model with only demographic characteristics did have some predictive value, but compared to the other two types of models, that is national political variables or geographic variables, it was the least predictive. The model with all three categories of variables did perform the best, but the contribution of demographic variables to the overall model was very small. And so just to presage what I think this means, and it's always hard to say what a non-finding is, but I think what this is suggestive of is that the local communities are not what are driving conflict, that it's more like they get caught up in conflict that's kind of created outside of the system of the local community. Now, we can't obviously prove that, but this is suggestive of that. As I said, the demographic characteristics do matter to some extent. And I just want to show you this, this figure, which goes over what our demographic characteristics were. And the way that you can read this figure is it shows the relative influence of each demographic variable and how it affected the model. So high values, which are red values, let's just look for a moment at women's household power, which is the average number of decisions in a household that women make within each community. The high values, or the red values, are having a negative effect. In other words, they're below 0. So they're having a negative effect on predicting conflict. While blue values, so high women's decision-making power, you're seeing more of that on the right side of the 0, which means that those things tend to have a low, they're having a reduced impact, they're reducing the impact of armed conflict, which is what you would expect. In other words, when women are making more household decisions, that's associated with less conflict. When women are making more household decisions, that's the opposite, that's associated with less conflict. When women are making more household decisions, that's less conflict. When they're making fewer household decisions, that's associated with more conflict. And you see a similar pattern if you look at women's media access. You see the red on the left and the right on the blue on the right. And you also see this with average women's education. Whereas things like the percentage of women who are opposed to intimate partner violence has the opposite effect. So that's kind of an interesting finding. Okay, so let's talk about the implications. So what we think we're seeing, as I mentioned earlier, is that local communities' demographic, so the findings are that local communities' demographic characteristics are relatively unimportant in predicting the outbreak of conflict. And we think that this may indicate that local communities are often more caught up in conflict rather than the instigators of it. But we think that more research is necessary to really determine if that's the case. And to the extent demographic characteristics do matter, women's empowerment does seem to provide some buffer against conflict outbreaks, which is consistent with information that previous research has seen at the national level. There's another component of the project, which is focus group discussions with conflict survivors in East Africa. And we're working with the Center for Victims of Torture. One of my other former graduate students, Shannon Golden, is the head of research for Center of Victims of Torture. And that group is very good at, their goal is providing mental health support for survivors of torture. And so they're an appropriate partner to be leading those focus groups, which require obviously a really high level of sensitivity. But we're able to get more information on gender with respect to that. So I just wanted to mention that we have that other component. Okay, well, thank you very much.